In this episode, we're going to talk about a kind of OT environment that beginners often misunderstand because it does not match the modern picture of everything being connected, standalone systems, and standalone networks. A standalone system is one that is intentionally separated from other networks, especially the internet and corporate networks, and it may even be separated from other OT segments. You might hear people casually call this air-gapped, but the deeper idea is not a dramatic gap in the air. It is a deliberate design choice to reduce exposure and control change. Standalone does not mean it is old, and it does not mean it is automatically safe, but it does mean that connectivity is limited by design. These systems exist across critical infrastructure sectors because some operations are so sensitive, so safety critical, or so hard to recover that organizations prefer isolation as a risk reduction strategy. For exam thinking, you need to recognize what standalone looks like, why it exists, and what security challenges remain even when a system is isolated. Once you understand that, you will stop assuming that every OT environment has a normal network perimeter, and you will start thinking about the real pathways that still exist. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A standalone system is usually built around the idea that fewer connections mean fewer ways for a threat to enter, but that idea only works when the remaining pathways are managed. Many beginners imagine an isolated system as a locked box that nobody touches, yet in reality, standalone systems still need maintenance, updates, backups, configuration changes, and troubleshooting. Those activities create touch points, such as removable media, portable devices, vendor laptops, and occasional temporary connections. Standalone can also mean a system is isolated during normal operations, but connected during maintenance windows, which can be a risky moment if controls are weak. Another important point is that isolation is sometimes partial, meaning a system might be isolated from the internet, but still connected to a local network, or isolated from corporate IT, but still connected to a plant-level network. A standalone network might be self-contained within a facility, with its own switches, workstations, controllers, and servers, and no direct routing outward. That design reduces exposure to external scanning and remote attacks, but it also means monitoring and centralized security tooling may be limited. The beginner lesson is that isolation changes the threat landscape, but it does not eliminate it, and you must understand the specific boundaries to understand the risk. Standalone systems show up in many critical infrastructure sectors because the processes involved are essential and sometimes dangerous. In the energy sector, there may be control systems for generation, transmission, or protective relaying that are kept isolated to reduce the chance of remote manipulation. In water and wastewater, certain treatment processes or chemical dosing systems may be isolated to reduce risk to public safety. In transportation, signal control or safety systems may be segmented heavily because disruption can create immediate physical danger. In manufacturing, a standalone cell might exist where intellectual property is sensitive, or where downtime is unacceptable, or where the equipment is specialized and must remain stable. In healthcare-related infrastructure, building systems and specialized equipment networks can be isolated to protect reliability and patient safety. In government and defense-related environments, isolation may be used for high-assurance systems where confidentiality and integrity are critical. The sector examples matter for the exam because questions may describe an environment without naming it directly, and recognizing why isolation would be used helps you interpret the scenario. You do not need to memorize a list of sectors as trivia, but you should be able to recognize the pattern: high consequence, limited tolerance for disruption, and high need for controlled change. It is also important to understand why some standalone environments remain standalone even when technology makes connectivity easy. Sometimes the equipment is legacy and cannot safely support modern network features without risk of instability. Sometimes the organization cannot afford to validate changes frequently, so it prefers an environment that changes slowly and predictably. Sometimes regulatory or safety requirements push towards separation. especially where a safety case depends on limiting external influence. Sometimes the environment is physically remote, like a site with limited connectivity, so it naturally operates in a more isolated mode. Sometimes the organization wants to limit data leakage or protect proprietary process information by keeping it off broader networks. These reasons are not excuses to ignore security. They are part of the context that shapes security strategy. A beginner should learn that security is about managing risk within constraints, and isolation is one of many tools. However, isolation can create a false sense of safety if people assume it eliminates the need for strong controls. The exam often tests whether you understand that standalone is not the same as secure by default. A major security challenge in standalone environments is the human pathway, meaning the ways people carry information and software in and out. Removable media is the classic example because it can transport malware, unauthorized tools, or altered files into an environment that does not have constant connectivity. Portable laptops used for maintenance can serve the same role, especially if they are used in multiple environments or if they are not managed carefully. Even printed documents and handwritten notes can be security concerns in high-sensitivity environments because they can carry sensitive information out. Another pathway is vendor support, where a vendor may need to provide updates, diagnostics, or configuration changes, sometimes using their own devices. If the organization does not control those interactions, isolation becomes porous in practice. Backups and restores are also pathways, because the media used for backup can be contaminated or the restore process can reintroduce old vulnerabilities. The beginner mindset should be that standalone shifts security from network perimeter defense to strict control of physical and procedural access. Your question becomes, who touches the system, with what devices, and under what rules? Physical security matters even more in standalone environments because physical access can become the primary attack path. If an attacker can reach a cabinet, a workstation, a network port, or a removable media slot, they may be able to influence the system despite the lack of internet connectivity. Physical security includes locks, controlled areas, cameras, visitor procedures, and supervision, but it also includes less obvious details like whether equipment rooms are shared with other functions or whether ports are exposed in public areas. In critical infrastructure, facilities may have multiple contractors and maintenance staff, and strong physical security procedures help ensure that access is appropriate and accountable. Another physical concern is environmental conditions, because harsh environments can cause failures that look like security issues, and vice versa, which complicates response. In OT, a device failure can cause process disruptions, and standalone environments may have less remote monitoring, so detection can be delayed. This makes physical inspection and routine checks more important, but those checks also introduce more human interaction with the system. For exam scenarios, if you see a standalone system with weak physical controls, that is a red flag, because isolation without physical discipline is fragile. Another challenge is visibility and monitoring, because many security tools assume network connectivity, centralized logging, and continuous updates. In standalone OT environments, you may not have the same level of centralized telemetry, and you may not be able to send logs to an external system easily. That does not mean you give up on monitoring, but it does mean monitoring may be local, periodic, or based on manual review. Operators and engineers may rely more on local alarms, local logs, and physical observations. Incident detection can be harder because abnormal behavior might be noticed only when a process changes or a device misbehaves. This increases the importance of baseline knowledge, meaning knowing what normal looks like in terms of system behavior and process behavior. It also increases the importance of change control records, because if something changes unexpectedly, you need to know whether it was an authorized change. A beginner should recognize that isolation can reduce the chance of certain attacks, but it can also reduce the speed at which you detect and investigate issues. The security strategy must account for that by strengthening procedures and local accountability. Standalone networks also have unique architecture patterns that beginners should recognize at a high level. A standalone OT network might include controllers, operator workstations, engineering stations, and a historian, all connected to local switches with no routing outward. Sometimes there is a one-way data path where processed data can flow out for monitoring or reporting but cannot flow back in, which limits remote control risk while still providing visibility. Sometimes there is a data transfer station where files are scanned and approved before being moved into the isolated environment. Sometimes there is a strict process for introducing updates, such as testing them in a separate environment first and then applying them during planned outages. These patterns reflect a security philosophy based on controlling interfaces and limiting trust. You do not need to memorize technical diagrams to understand the principle. The fewer controlled gateways you have, and the better you manage them, the stronger the isolation. However, if gateways exist but are poorly managed, they become high-risk points because they are the bridges into the standalone environment. Exam questions may describe a bridge point indirectly, like a laptop used to move files between networks, and your job is to recognize it as a critical control point. Once you see bridges clearly, you can reason about what safe controls should exist around them. It is also important to distinguish standalone from simply older or smaller, because those are different ideas. A small localized control network might be connected to a plant backbone, while a standalone network might be large and sophisticated but intentionally isolated. An older system might still be connected if the organization needed remote visibility, while a newer system might be isolated if the organization prioritized separation. Standalone is a design choice about connectivity and trust boundaries, not a label of maturity. Another subtle point is that isolation can be unintentional, such as when a site loses connectivity due to failure or maintenance, and then operates in a standalone mode temporarily. In those cases, procedures must support safe operation without remote support, and the return to connected mode must be controlled. This kind of transition can create risk if configurations drift or if temporary fixes become permanent. Beginners should understand that networks can shift between connected and isolated modes, and security must consider those transitions, not just the steady state. Transition moments are when mistakes and misunderstandings are most likely. A common misconception is that if a system is isolated, it does not need patching, strong authentication, or careful configuration. In reality, vulnerabilities can be exploited through local access, and compromised removable media can deliver malware that does not need the internet to cause harm. Another misconception is that isolation always prevents data from leaving, but people can still exfiltrate information physically through screenshots, photos, copied files, or removable storage. A third misconception is that standalone systems are easier to manage, but they can be harder because updates and monitoring require more manual effort and more discipline. There is also a misconception that isolated environments can ignore governance, but governance becomes more important because so much depends on procedure and accountability. The best security in standalone OT relies on consistent control of who can access the system, what they can do, how changes are approved, and how media is handled. These are not glamorous controls, but they are effective when applied consistently. For exam purposes, the right answer in a standalone scenario often involves strengthening physical and procedural controls rather than adding network-based controls that assume constant connectivity. To close, standalone systems and networks are common across critical infrastructure sectors because isolation can reduce exposure and help preserve safety and stability in high-consequence environments. Standalone means connectivity is deliberately limited, but it does not mean risk disappears, because maintenance, updates, and human interaction still create pathways into the system. The most important risks often shift toward removable media, portable devices, vendor access, and physical security, along with challenges in monitoring and incident detection. Different sectors use isolation for different reasons, but the pattern is consistent: high impact, low tolerance for disruption, and a desire for controlled change. When you recognize standalone environments in exam scenarios, you can reason about what controls matter most, focusing on managing the remaining interfaces and strengthening accountability. This mindset will help you avoid the trap of assuming every security problem is solved by network tools, because in isolated OT environments, discipline and controlled interfaces often matter more than fancy technology. If you can explain why a standalone network exists, how it can still be compromised, and what practical controls reduce that risk, you are thinking in the way Security OT Plus is designed to measure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.